Hi everyone. Today we're going to be talking about something called the factored form of quadratics. So go ahead and follow along with your notes, and if you have any questions, feel free to ask. Equations of quadratic functions take many different forms. One form of quadratic functions is called factored form. Factored form. Factored form looks like something like this. We call this the function x equals a multiplied by x minus p and multiplied by x minus q. Okay? So a, p, and q would all be different numbers. Okay. So things to note here are that if a, so meaning this number up front, if it's positive, the parabola is going to open upwards. So that would be something like this. And that means it would have a minimum. If a is negative, that means that the parabola will open downwards. So that means it'll look something like this, meaning it would have a maximum, a very high point. Okay? In these notes, the following notes are ways that you're going to be able to find all of those key characteristics that we talked about last time, like those x-intercepts, y-intercepts, vertex, and axis of symmetry. So to find the x-intercepts of a quadratic function in factored form, you're going to set each factor equal to 0. The factors are these things in the parentheses right here. So basically you'd say x minus p equals 0 and x minus q equals 0, where p and q would be different numbers. To find the y-intercept of a function, you're going to substitute 0 for x. To find the vertex of a quadratic, remember that's just going to be at the midpoint. You find the midpoint between the roots, which remember that's the same word for x-intercepts, and substitute that x value into the function. And then finally, the axis of symmetry will match the x value of the vertex. So if you have two roots like that, and you find the halfway point, that means that you found the axis of symmetry. And then the vertex would is going to be down here or somewhere up here, depending on how you substitute it in. Okay? So let's see some examples so we can understand how this works. Okay, so this is the first example. It says f of x is equal to 2 multiplied by x minus 3 multiplied by x plus 1. So to find my x-intercepts, just like my notes said, what I'm going to do is I'm going to take each factor, this x minus 3 and this x plus 1, right? And I'm going to set them equal to 0. So that means I'm going to take two equations. I'm going to say x minus 3 equals 0. And I'm going to put another equation, call that x plus 1 equals 0. And then I solve them both out. Now both of these are going to be one-step equations. So that means I just add 3. So in this case, x is equal to 3. And then for my other factor, I subtract 1. It means x is going to equal negative 1. Oh, so I just figured out my two x-intercepts. One of my x-intercepts is going to be at 3, 0, and one is going to be at negative 1, 0. So here's 3, 0. and here's negative 1, 0. Great, so I just figured out my x-intercept. Now I need to figure out my y-intercept. So to figure out my y-intercept, my notes tell me that I just need to substitute 0 for x. So that means instead of this x and instead of this x, I'm going to write zeros. Alright, I'm going to write f of x, or actually f of 0, right, because I'm replacing all the x's with 0, equals 2 multiplied by 0 minus 3 and 0 plus 1. All I did was instead of these x's, I wrote 0. Okay, so now I write 2, and I do the operations in my parentheses. 0 minus 3 makes negative 3, 0 plus 1 makes positive 1. All these parentheses just mean that I multiply, so that means f of 0 is equal to 2 times negative 3, that makes negative 6, times positive 1, still negative 6. Oh, I just found my y-intercept is going to be at negative 6. So that's going to be 0, negative 6. So I figured out my x-intercepts, I figured out my y-intercept, now I need to figure out my vertex. So my vertex, based on my notes, means that I need to find the midpoint. This is going to be helpful actually for both the vertex and the axis of symmetry. Okay? So what that means is that between my two roots, I need to find the middle point. So if I could actually just count how many spaces are in between here. So from negative 1 to positive 3, that means I have 1, 2, 3, 4 spaces. So halfway between 4 spaces would be 2 spaces. Right here, 1, 2. Oh, halfway, 1, 2. So that means that my axis of symmetry is going to be on x equals 1. And that means that I also know that my vertex is going to be 1 comma something. So all I need to do to be able to figure out what that y value is of my vertex is to actually substitute it into the function. So just like I did with the y-intercept, except I'm not going to plug in 0 now, I'm going to plug in 1. So I'm going to write this over here. I'm going to say f of 1 equals 2 multiplied by, instead of x, I'm going to write 1. 1 minus 3 multiplied by 1 plus 1. So this is where the x's were. And instead of the x's, I wrote 1. Okay? So now I just follow order of operations. 1 minus 3 makes negative 2. 1 plus 1 makes positive 2. 2 times negative 2 makes negative 4. Multiplied by positive 2 makes negative 8. So f of 1, so that means 1, negative 8 is going to be my vertex. So I go to 1, negative 8, that's right here. And with those, now I have 1, 2, 3, 4 points that let me know what my parabola is going to start to look like. And my axis of symmetry shows me where it's going to be split in half. So I connect from left to right, so this is the leftmost point, to this point, to this point, and back up through here. If I use my axis of symmetry, I also know that there's going to be, if this is 1 off here, then this is going to be 1 off here. So that means that I can actually find another point as well right there. And that's how you can get a shape of a parabola using the x-intercept, y-intercept, vertex, and the axis of symmetry. Okay, so let's try the next example. This next example says g of x, and this is just the name of the function. It's the same thing as y, it's just that I'm calling it g, or I'm calling it f, or I'm calling it h. It's just all different variables. G of x is equal to negative 2 multiplied by x multiplied by x minus 4. So, first thing to find my x-intercepts, set factors equal to 0. So my factors again are x and x minus 4. So to find my x-intercepts, going to say x is equal to 0. I'm going to say x minus 4 is equal to 0 as well. Let me write that a little more neatly. So x equals 0. I actually don't have anything to solve here, so I know that one of my x-intercepts is going to be at x equals 0. X minus 4 equals 0. I still want to get this x by itself, so I do the inverse operation. I add 4 to both sides, and I get x is equal to positive 4. So now I have two x-intercepts. One of them is 0, 0. That's from this one right here. And then my other one is going to be 4, 0. So I'm just going to plot those 2 points. I've got 0, 0 right here, and then 4, 0 right here. Alright. So now I move to my y-intercept. My y-intercept tells me I replace x with 0. Okay? So if I replace x with 0, let's see what that looks like. So that means g of 0 equals negative 2 multiplied by 0 multiplied by 0 minus 4. Follow order of operations. Negative 2 times 0. 0 minus 4 makes negative 4. Negative 2 times 0 is 0. 0 times negative 4 makes 0. And I actually already knew that because there's only one y-intercept, and this one actually matches with one of the x-intercepts. So my y-intercept here is 0, 0. My vertex and my axis of symmetry, I need to find the midpoint. So let me find the midpoint between these two right here. So between these two roots, I've got 1, 2, 3, 4 spaces. So if I've got 4 spaces, half of 4 is 2. So 2 spaces, 1, 2, 1, 2. So that means that my axis of symmetry is going to be on x equals 2. So that also means that I know the x value of my vertex is going to be 2, and I still need to figure out the y value. So how I figure out the y value? Replace x with midpoint. And my midpoint in this case is 2. So I'm going to write g of 2. I'm just going to take this function and replace all the x's with 2. G of 2 equals negative 2 multiplied by positive 2 multiplied by 2 minus 4. So this one was an x, this one was an x, and this one was also an x. So now I just solve that out. So negative 2 multiplied by 2, follow my order of operations, so I do my parentheses first. 2 minus 4 gives me negative 2. Negative 2 times positive 2 gives me negative 4 multiplied by negative 2. So it's going to be super important that you keep track of your negatives and positives here. Negative 4 times negative 2 gives me a positive 8. So I know that g of 2 is equal to 8, meaning that my vertex is 2, 8. So I find 2, 8, that's to the right 2, up 8 spaces. So with that information, I've now got these 3 points that can make my parabola. So I'm just going to connect them from left to right. So that means I got to go up, and then down again. And make sure that you draw it as a curve because it is a parabola and not a straight line. Okay. This would be a good time to pause, try example 3 on your own, or you can just watch the video and follow along with me again. So first, I want to find my x-intercepts. I set my factors equal to 0. So that means this factor, x minus 1 and x minus 3. to make two separate equations. X minus 1 equals 0, x minus 3 equals 0. To get x by itself here, I add 1, that makes a 0 pair, so x is equal to 1. I found one of my x-intercepts, 1, 0. Here I add 3, here I add 3, I make a 0 pair, so x is equal to 3. So that's my other x-intercept, 3, 0. So 1, 0 is right here, 3, 0 is right here. For my y-intercept, I need to replace x with 0. So I'm going to write h of 0 equals, put zeros in here, h of 0 equals 3 times 0 minus 1 and 0 minus 3. 0 minus 1 gives me negative 1, 0 minus 3 gives me negative 3. All these parentheses now mean multiplication. 3 times negative 1 is negative 3 times negative 3. Negative 3 times negative 3 gives me a positive 9. So my y-intercept, here, is going to be 0, 9. And in this case, it's actually going to be off the graph. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be somewhere really high up here, actually. 4, 5, 6, 7, 8, 9. Let's say it was right here. I apologize for not having a big enough graph for this one. Okay. And then finally, if I'm going to try and find my vertex and my axis of symmetry, I need to find the midpoint between the roots. So if I find my midpoint, right now I see that there are 1, 2 spaces. So half of 2 spaces gives me 1 space. So 1 space over and 1 space over. So that means that my axis of symmetry is going to be right in the middle at x equals 2. It also means that my vertex is going to have an x value of 2. So now I take my function, and instead of replacing zeros, I'm going to put 2's to figure out what my vertex is. So h of 2 equals 3 multiplied by 2 minus 1 multiplied by 2 minus 3. So that's 3. 2 minus 1 gives me 1. 2 minus 3 gives me negative 1. This is all multiplication. 3 times 1 gives me 3. Times negative 1 gives me negative 3. So h of 2 is going to be negative 3. So my vertex is at 2, negative 3, so that's to the right 2 spaces and down 3 spaces. I found my vertex right here, my x-intercept right here, and my y-intercept way up here. So now that I have all those points, I can connect them from left to right. So I'm going to start with this green dot up here, go to this blue dot, then the red dot, then the blue dot. Then I know that since it's symmetrical, it's going to go back up like this. And then this is an example of a parabola that has a minimum. Okay? If you have any questions, please let me know. And that's the video for today.